All right, in this example, we're going to use the properties of logarithms to rewrite the expression given. Now, we're given a single log here, and when you're given a single log and asked to rewrite it using the properties of logarithm, you're probably going to be just simply expanding that log. Now, the other scenario you can have, and I believe that's the next problem, is when you're given it in expanded form and you're asked to write it as a single log. Okay, so let's focus on this problem. We want to expand it. So we're going to first start by removing the radical. So we're going to write the expression itself that's underneath the radical. We're going to write that as a fractional exponent. In other words, it's going to have an exponent of a fraction. So recall, I'm going to show you an example. For example, let's say if I have the square root of x over y. So if I have an expression like the square root over x over y, that would transform into x over y raised to the 1/2 power. And the reason you have the 1 on top of your fraction is because the whole radical itself, it was not raised to any power. Now, if it were raised to a power, that number would go up top. But since it wasn't raised to any specific power, we write a 1 up top. And because this is square root has an index of 2, so that is why you would have 2 under the bottom. Now let's focus here on back again at our example here. So that means for my fractional exponent, I'm going to have a 1 up top because the expression is not raised to, the whole thing would have to be raised to a power, and it's not. So I'm going to have a 1 up top. This is 5th root, so I'm going to have a 5 under the bottom. So when I rewrite it, it's going to look like so. My next step, since I have an exponent here of 1/5, by the power rule of logarithms, it states that you can bring this fractional exponent here, which is your exponent, bring it out front of that log. So when we do so, it looks like so. Next, well, let's focus our attention on this fraction. That's the quotient rule. So anytime you have a rational exponent or something in fraction form, that's the quotient rule, which is going to be top take away the bottom. So log of x squared minus log of y to the 4th power. And we'll keep that 1/5 outside. Next, you notice that these logs have an exponent. The first one has an exponent of 2. The other one has an exponent of 4. And that's the power rule, which means that we can move those out front of their log. So let's go ahead and do that. And lastly, we can go ahead and use the distributive property. 1/5 times 2 log x is going to be 2/5 log x. And then 1/5 times -4 log y is going to be -4/5 log y. And there you have it. We have it now in its expanded form. In this example, we're asked to express this log as a single log. So this time we're going to do the reverse. We want to write it as one single log instead of an expanded form of a log. So looking at what we're given, I see here we have a subtraction sign, which means that we're going to have the quotient rule involved. So it's going to be this log on top and this under the bottom, and log base b with the m on top and the n under the bottom. And I see plus you have a log in the back. So recall, when you have plus, you're going to wind up multiplying some logs there. I also see a 3 in front of the log, which that's something that I can move to the back of the exponent. But let's do one step at a time. So step 1, let's go ahead and consolidate these two logs into one log. Since they both have the same base, we can do that. So it's going to be log base b of, and then it's going to be m on top, take away the n on the bottom. That's called the quotient rule. Next, we're going to move that 3, that's a power rule, out to the back, which is going to be that exponent on that k. Good. And let's see, what else can we do here? Well, we have a plus sign, and a plus sign is the product rule, which states that if two logs have the same bases, that you can go ahead and multiply their terms. So what we'll have there using the product rule is log base b of m over n times k to the third power. Now you can also write it with k on the side or k on top, because recall that any number on the side is the same thing as being on top. And there you have it. Rewriting or expressing a log, an expanded log, as a single logarithm. In this example, we're asked to evaluate the logarithm log base 3 of 25 using the change of base formula, and then round our answer to 2 decimal places. In other words, leave 2 numbers up past the decimal. So let's get started. Here we're given log base 3 of 25, and recall the change of base formula is as follows. For example, log base b of x is the same as saying log x over log b. You can think of it as kind of moving in a backward motion here. So you have the log, and then you have x, which would be on top, and then b is on bottom, so log x over log b. So using the given log we're given, it would be log 25 on top, and then moving backwards here, and log 3 under the bottom. So it will be log 25 over log 3. And from that point, all you need to do is just get your scientific or graphing calculator and type in log 25 divided by log 3, because you know that anytime you have it in fraction form or as a quotient, that it's a same thing as division. So go ahead and do that, and let's see what you get. So again, log 25 divided by log 3. Press enter. You're going to get approximation, and we want to leave 2 numbers up. So let's count over first at 3. 1, 2, 3, because you always count over one more than that place. Now, if this number, which is in this case is a 9, if it's 5 or more, which it is, it makes the next number in front one more. So you're going to have 2.93, and the answer is D. And there you have it, change of base formula. In this example, we're going to solve an exponential equation. So step 1 would be to find common bases. So you can't break 3 down. So we look at 12, and can you have a base of 3 and somehow produce a 12? Well, the answer to that is no. You can even test it by saying 3 squared, that's going to give you 9. 3 cubed, that's going to give you 27. You're already over. So you cannot create like bases with this. So let's use some other method. How about if we use the change of base formula? So when you don't have a common base, then one method you can use is called the change of base formula. So rewrite it back as a log. And recall how we converted from log to exponential and then exponential to the log. We did that in an earlier section. So to create something in log form, log base b of x. So our base here would be 3, so that's going to be log 3. Our answer here is 12. So it's going to be log base 3 of 12 is going to equal x. So there you have it. Now let's use the change of base formula. Remember, with the change of base formula, it's going to be log 12 on top and then log 3 on bottom when you rewrite it. Get your calculators out. Go ahead and key that into your scientific or graphing calculator. Log 12 divided by log 3. You should get an approximate answer. And you should have gotten these digits. And which one of those choice when you round it to 3 digits? You got it. Choice B. There you have it. Solving an exponential equation that does not have a common base using the change of base formula. Let's look at another way we could have solved that problem. So again, our given problem was 3 to the x is equal to 12. We could have also took the natural log of each side. So again, when there's no common base, you can take the natural log of each side. And we still want to solve for x. That's with any case in solving an equation. Now, by the power property, when you have an exponent here, recall we can bring that exponent out in front. So let's go ahead and do that. That's a power property. Again, we want to solve for x. So to get x by itself, right now x is being sandwiched with or multiplied with the natural log of 3. So what we have to do is get rid of the natural log of 3. The opposite of multiplication is division. So I have to divide by the natural log of 3. And recall with equations, whatever you do to one side, you must also do to the other side. So what you're going to have then is x equals the natural log of 12 over the natural log of 3. So now you're ready to get your scientific or graphing calculator out, and you're going to type in the natural log of 12. So find the ln key and then type 12 divided by the natural log of 3. Enter. It's going to give you an approximation. And rounding that to 3 decimal places should give you which choice? You got it. B. That is correct. In this example, we're going to solve another logarithmic equation. Log base 5 of x plus 2 plus log base 5 of x minus 2 is equal to 3. Well, the first thing I want to do is to rewrite the left side as one single log. So we have 2 of the same log, log base 5. So we can use the product rule to rewrite that expression. So once we do so, remember when you see 2 logs that are split up and they're added together, that is the same as bringing them together as one log and then multiplying them together. So once we do so, it's going to look like so. Our next step is we're going to rewrite the equation in exponential form so that we can solve. So recall the snail-like circular pattern or counterclockwise, starting with the base, 5 raised to the third power equals the binomials of x plus 2 times x minus 2. And what that is nothing more than a difference of square. We can write that in short form as x squared minus 4. So we have 5 to the third power. When we multiply the number 5 3 times, we get 125. And on the right side, we have a difference of square. Next, we're going to add 4 to each side so that we can isolate the squared term. Our next step to finding x, to solving for x, is to simply take the square root of both sides. Whatever you do to one side, you do to the other. And x equals the square root of 29. And there you have it. In this last problem, we want to know how long will it take for prices in the economy to double at a 9% annual inflation rate. Round your answer to the nearest year. So, and we're also going to use the A equals P times e to the RT formula whenever we want to find out how much something has doubled or increased over a period of time. So plugging in everything we know to find out what we don't know. We know the interest rate is 0.09 when we convert it to a decimal. Double, when something doubles, it's twice that. So when we rewrite this formula, what we're going to have to write it as is A equals 2P. So the amount is not just a single amount. It's going to be twice that. So writing that at your new formula now is going to be 2P equals P times e to the RT. Because again, we're doubling it, that amount, not just one single amount. Let's go ahead and plug in our rate. So our next step for solving this equation is we want to remove the P, in other words, get E by itself. To do that, we're going to have to divide by P. So whatever you do to one side, you do to the other. Now that we have the E isolated, we're going to take the natural log of each side. Our next step to solving this is we're going to go ahead and cancel out the natural log of E, because recall the natural log of E equals 1. So we're left with 0.09 t on the right side. Last step to solving for t is to divide by 0.09. Whatever you do to one side, you must do to the other. And on your scientific or graphing calculator, you're going to type in the natural log of 2 divided by 0.09. It's going to give you an approximate. And you're going to round it to the nearest whole year, which will be 8 years. And there you have it. Okay, that's it for this review. I hope you found it to be helpful. Stay positive, stay focused, study, and make it happen. But most of all, thank you for watching math videos on PowerPoint tutorial with Dr. Speights. Please like, share, and subscribe.